Hello, my name is Tyler Denton. I'm a solutions architect with the Couchbase Center of Excellence. First off, I want to say thank you for attending my presentation, and also thank you for attending Connect. Obviously, these things are successful based on the people that attend and the interaction that we have through them. As you can see, this presentation, like the other presentations, is a Simu-Live presentation. So while this is pre-recorded, I will be available in the chat window to answer any questions or go over any comments that you have about the presentation. So please ask your questions, give me your comments and feedbacks, and I will answer as I can. All right. So in this presentation, we're going to touch on monitoring. So why to monitor and one specific way of monitoring Couchbase. We're going to get into the individual pieces and parts of this monitoring solution. We're going to look at how the monitoring solution or the exporter itself was created in the Couchbase Center of Excellence and how it works, obviously. We're going to look at the many different deployment options using this exporter. In the solution, we use Prometheus. So we're going to get into how to configure Prometheus. We also use Grafana. So we're going to look at how to configure Grafana. And then in the end, we're going to get into the real reason you're here, and that would be the demo. All right, so here we're going to get into how to monitor, why to monitor, get to see some of the benefits of monitoring along with the high-level architecture of this monitoring solution. So why to monitor? One of the benefits of monitoring is it gives you an understanding of steady state operations. So with steady state operations, you're able to reduce noise and see how things are changing over time. So you get to perform trend analysis. You get to see if a spike is something that is actually important or if that's just within the noise of your system. Monitoring allows you to identify what's causing noise and reduce that noise. Monitoring can also help us improve resource allocation. So if we wanted to make sure that our clusters weren't oversized or our clusters weren't undersized, let's say we had multiple clusters and some of them were oversized and some of them were undersized. Well, what we could do there is take resources from one cluster and apply them to the other. Or we could see that maybe we could combine clusters, or we need to split apart clusters, or split apart buckets. Monitoring helps us identify these issues. We don't want undersized clusters because it can lead to poor performance. And we don't want oversized clusters because that is wasting money through TCO. I've got a couple customers where I've done monitoring engagements where the whole point was to go out and set up their monitoring solution. These customers have had previous poor experiences with tickets or something like that. And going through and building out a monitoring solution for them, we were able to identify where we've had issues. And from there, build out a solution that helps them better understand their cluster and greatly reduce the number of tickets, the number of outages, things like that. Monitoring can also include alerting. So let's say that we exceeded 80% memory utilization in our cluster, and we don't ever want to do that for whatever reason. We can build out alerting that's going to tell us if we ever exceed these thresholds. We can also build out alerting based on, the slope of our memory increase. So every month we expect our average memory to go up by 1% or whatever. Well, based on that, we can say if we exceed that 1%, let's say we hit 7% over whatever period you're looking at, well, we would want to alert based on that. That's something that could be very helpful for preventing issues before they actually become issues. Having good monitoring gives us a lot more information about what's happening in our system. So we are able to resolve tickets much faster. So if you have a deployment where your gets per second go from 1,000 to 5,000, but your number of customer interactions didn't go up, well, maybe that's a problem with your deployment and something happened with a covered index or something like that. monitoring can help you identify those issues and head them off. It's much better to be fixing a problem before it actually becomes a problem than it is having somebody breathing down your neck to get a system back up after it's broken. All right, so here we're going to look at the overall architecture of the solution that we built. So in this section, you can see that we have a Couchbase cluster that's set up, and on each of our Couchbase nodes, we have what's called a node exporter and a process exporter installed. The process exporter and the node exporter allow us to get information about the system that Couchbase is running on, and we'll get into more about that in a minute. Then we have our Couchbase exporter, which is running external to all of our Couchbase nodes. We have Prometheus that's scraping the exporters. Prometheus is also providing information to Alert Manager and Grafana. And you can see that we've got these all built out on different machines, but this is obviously very customizable for whatever it is that you want to do. So overall, Couchbase in a cluster, node exporter and process exporter running on Couchbase. The Couchbase exporter is running external. Prometheus scrapes the exporter scrapes Couchbase. Alert Manager monitors Prometheus, and Grafana monitors Prometheus. And Grafana is what we use to dashboard our metrics. All right, so here we're going to get into looking at Prometheus. If you haven't used Prometheus before, it's very similar to like StatsD and Graphite or Carbon. It is a open source metrics-based monitoring system. And what that means is that you can go and build it yourself. You can make edits. You can issue pull requests or create issues in their repos. You can monitor pretty much anything that you want with it that works as a time series. So if you're wanting to know how many times something happens per second over a year, or maybe not a year, but over 2 weeks, Prometheus is a great thing to do that. One of the differences between Prometheus and StatsD is that Prometheus is a polling solution where StatsD is a pushing solution. So instead of having something that's sending metrics over UDP to Prometheus, like it does in StatsD, Prometheus actually scrapes an endpoint, typically the /metrics endpoint of a REST API that you have to set up, unless your application that you're running has a Prometheus endpoint built into it already. Prometheus provides its own query language called PromQL. And what PromQL does is it allows you to run very complex calculations or statistics or build out your own metrics based on other metrics as values, or just as simply as just give me this metric. It can go from very simple equations or queries to very, very complex, much like any other query language. Overall, setting up Prometheus is very simple. It's very, very easy to run. It can even run in a container. So the standard deployment for Prometheus is actually containerized. So when you go to their website and look at how to set it up, most of their instructions are around containers. And if you were to look at their website, it's going to be here. So Prometheus.io is the website for Prometheus. And please, if you have questions about any of this, please ask in the chat box. So now the node exporter. So the node exporter is a process that's provided by the Prometheus project. It runs on each Couchbase node, and it exposes hardware and kernel related metrics. So if you want to see what's actually happening with your Couchbase node that Couchbase server is running on, this is a great tool to use. There's lots and lots of other tools out there. Datadog has some, VictorOps has some, anything where you're monitoring system level metrics, you can use. This one we chose to use because it is provided by the Prometheus project and it fits with the ecosystem really well. And obviously it provides a Prometheus/metrics endpoint for Prometheus to scrape. This captures metrics that are not currently captured by Couchbase. So running on the Couchbase process, we have a lot of metrics that we collect, but we can't get all the metrics about the system. So we have the node exporter running on each node in the cluster just going to go through and gather metrics about the system. And so we've got this set up to run on each node in the Couchbase cluster. We also have this configured to run on the exporter itself. So the exporter is able to monitor its own health. And then since it's maintained by the Prometheus project, you can find it at prometheus.io/docs guides node exporter. And you can go look at it and see how it runs. It's a very simple, very small process that uses very little resources to generate its metrics. Process exporter. So the process exporter is similar to the node exporter, except you can configure it to run whichever or check and monitor whichever processes that you want it to monitor. So it mines the /proc to report on selected processes. And once again, it captures metrics that aren't available to Couchbase. So if you're also running Nginx on your system, which you shouldn't do, but let's say you are, you could have the process exporter monitor and report on that process itself. Any other processes that are running that are not visible to Couchbase, you can have this monitor. It has a very simple configuration file. So you set up, the different processes that you want to monitor, and it will go start presenting data to Prometheus at its /metrics endpoint, and it will allow Prometheus to monitor these other services that are running on that node that Couchbase is running on that Couchbase doesn't have access to. And you can find it at this GitHub repo address. Alert Manager. So Alert Manager is a very important part of the Prometheus ecosystem. And what Alert Manager does is it takes the metrics that are being ingested into Prometheus, the time series database, and you build out a set of rules. And these rules tell Couchbase, or tell whatever route or alert endpoint you have about changes to the system that exceeds some threshold that you've set. So if you set, like I said earlier, memory above 80%, you want to alert on it, you have a rule set up that's going to be based on cluster memory or node memory or something like that. And that is going to have its own routes. And that route is going to direct those alerts to whatever target you like. Email, PagerDuty, OpsGenie, something like that. And the purpose of Alert Manager is to combine these alerts so that you're not getting multiple alerts over and over and over again. So deduplicate and group those alerts and route them, and also allow for silencing and inhibition of alerts. So a good example of that would be if you're taking a node down for maintenance, you don't want the Alert Manager to send messages to everybody saying that a node has gone down because you're expecting it to. Or you're doing network maintenance and XDCR is going to go down. Well, we can disable the alerts related to XDCR between these two clusters, do our maintenance, and not have everybody freak out about alerts being sent out. And so that's available at this location. So once again, part of the Prometheus project, prometheus.io/docs, alerting latest, and Alert Manager. This can also run in a container and is very, very simple to set up, although in my opinion, the configuration for this can get a little bit complex. All right, so here's the real work, the Couchbase COE metrics exporter. So this is the exporter that's been created by the Center of Excellence. We maintain it. We have a repo that's publicly available. So once you start working with this, please submit any issues, contribute, whatever you like. It would be very helpful to everybody in the COE and in the greater Couchbase community. If you can come up with a better name, please give me a better name. CB Prometheus_Python was a working name that just kind of stuck. So in the chat box, give me your better names. Maybe we'd come up with a poll or something like that. What this does is, if you've worked with Couchbase long enough, you know that there are many, many metrics endpoints in Couchbase. The node self endpoint, the pool's default endpoint, all the different endpoints associated with each service running on each node. And so what the exporter does is it goes and it scrapes all of those metrics for you. It then goes through and it processes those metrics into a Prometheus text format. There are additional metrics that it goes and gets that you wouldn't necessarily have access to directly from the REST API, and calculates out these richer metrics and presents them in a Prometheus format. The data that's then available is things like the slow queries report. The metrics exporter is also able to run stats-D. And so not stats-D, sorry, Cbstats. And so it will actually execute the Cbstats and collect Cbstats and present that as a endpoint for Prometheus to scrape as well. This is written in Python using Flask, and it's served with Uixie. The Python versions that it works in is now both 2.7 and 3.6. I haven't tested it in any other versions, but it should work in later versions of Python as well. Remember, better name. Give me a better name. So how does the exporter work? The first thing that happens is Prometheus makes a request to the exporter. So it has a set of metrics that it needs to get updated. These are called targets. And so those targets are exposed on the exporter as endpoints, as URLs. So it scrapes through those endpoints on the exporter. The exporter has logic built in that says, all right, somebody has requested this endpoint. I am now going to go and scrape through each one of the nodes in my Couchbase cluster and calculate the metrics and present that back to Prometheus in a streaming format. So the exporter goes and scrapes those metrics. Once it gets the metrics, it then starts streaming those metrics back to Prometheus in a Prometheus format. And then those metrics end up back in Prometheus. The trick with this is as long as Couchbase continues to follow the standard format it's been following for how to present metrics and the endpoints to use with the metrics, the exporter will always be able to get the metrics that are available to it. So if we add more metrics to the eventing endpoint, the exporter will just include those metrics in the later versions without us having to go and update the exporter or do any work around that. It can expose OS metrics that are available through Couchbase, data, query, index, full text search, eventing, analytics, XDCR. It actually will scrape the node exporter and the process exporter and can issue Cbstats. It will also query or generate the slow queries report that is then available in Prometheus to be presented in a Grafana dashboard. So this allows you to have, let's say, a user with no access to Couchbase but works in a DevOps role to monitor the cluster without ever having to access the cluster directly, because the exporter is what's actually accessing the cluster. And the exporter, you can build out a user to use this exporter that doesn't have permission to change any of the data in the cluster. So this is a very, very secure approach that doesn't present any private data, but still gives operators great visibility into what's actually happening in the cluster. To configure the exporter, it's really simple. There's 10 possible variables that you can configure, but we only actually require 3 of them. So we want to know the database that we're going to use. So this is the host name. We want to know the username and the password to access the cluster. And this should be like a read-only admin. And then if you want to start it with Uixie, it's just a very simple command, and poof, the exporter is running and exposing those metrics on, in this case, on port 5000. It's even simpler if you're going to run it with Docker. There, you're just going to edit the Docker file and run a Docker compose and Docker up, and now you've got a container that has the exporter running inside it. And instructions for all that are available in the repo itself in the README. Now, this way to get the exporter running using Uixie is great for testing and great for development. But when you actually want to start running this in production, we definitely recommend using Emperor with systemd and set your environment variables in Vassal files And there's a couple reasons for that we can get into when we start looking at the different deployment models. But the main reason is that systemd can restart your process automatically in the case of some kind of failure, or you have to restart the node or something like that. So Emperor, best to run with UXE. Once the exporter is running, we can issue git requests against the /metrics. And now that would give you every metric available in Couchbase across every node for every service. And that would take a long time to load. I don't recommend using that. I recommend using the specific service endpoints. So if we wanted to get information about the query service, we would issue /metrics/query. And this would tell us all the information about the query service, including our slow queries. There are some Git parameters that we can include in here for query. Let's say we don't want to get the slow queries report. Well, we can actually turn it off with slow queries equals false. We can also include the nodes that we specifically want to get information from. So we can include a list of nodes as a get parameter. Or we want to get information about the whole system. So we can pull the metric/system endpoint. And this is going to give us information about the system as a whole, not necessarily each individual service running on each node. And if you know a little bit of Python, you can take a look at our repo here, Couchbase Labs, cb_prometheus_python, and get looking into the source application views. And views contains a list of all of our endpoints, along with all their Git parameters and things like that. And so that'll give you a good understanding of how the exporter actually works. So deployment options. So the first one is one of the simpler ways to do this is to have one exporter that monitors multiple clusters. So here we have our Couchbase exporter, and we have cluster 1 and cluster 2. Running on each cluster is the node exporter and the process exporter. And we have one Couchbase exporter that's running using Emperor that has 2 vassals files. One vassals file is monitoring cluster 1, and the other vassals file is, well, it's not the file that's monitoring it, but the configuration for cluster 2. So Prometheus has its targets, it scrapes the CB exporter, and the Couchbase exporter scrapes its clusters and presents the data back. Now, the advantage to this is that there's one exporter running, so you can monitor lots of clusters. The process is pretty lightweight. It's easy to run, and you know where that exporter is, and it's simple to manage. The con here is that there's no workload isolation. So let's say cluster 1 has 300 indexes, and we're pulling metrics across every index. We are really having to make this CB exporter work to get all those metrics about all those indexes. And cluster 2 has like 5 indexes, and it's a 5-node cluster or something like that. Well, it would be very quick to scrape this cluster, but we're spending a lot of time and a lot of work scraping cluster 1. And while these do get processed in parallel, this workload is obviously going to impact some of the workload to scrape cluster 2. And so that can be a complication when you're running in single exporter mode. So this version is the most common version, or the most common deployment model for the exporter, and it's to run one exporter with every cluster. The best way to set this up is in some kind of Terraform or system that's going to say that every cluster you get a Couchbase exporter. This is easily the simplest to deploy. The problem with this is that there's no high availability out of the box. So if this exporter goes down, we are no longer monitoring cluster 1. If this exporter goes down, we're no longer monitoring cluster 2. And so that can be a problem. And so you would want to set this up. You could set this up in a way that we'll see here in a second. but this is definitely the most common way to deploy this. Here is, in my opinion, the best way to deploy this. It gives you high availability out of the box. In my opinion, it's easy to manage, deploy, and scale, and it can work with the Prometheus autonomous operator. The con here is that it does require some Kubernetes experience to manage. So the way I do this here is you build out 2 exporter pods, and these exporter pods are then fronted with a load balancer. And so we're load balancing the port 5000 on the CB exporter for each cluster. And so this gets configured to scrape each node in the cluster. If one of these pods goes down, the load balancer is going to direct traffic to the others. The load balancer endpoint is what gets included in the Prometheus target. And you can build this out with deployments so that as you add clusters, you can scale out your exporters as well. This gets even simpler if your Couchbase clusters are also in Kubernetes, but it doesn't require it. Now, you could do this same thing in a cloud environment or something like that with the ALB in front of your exporters, which are then scraping your clusters, but that could get pretty expensive. This way, it's all in software, and it makes things very simple and easy once you've got it up and running. Here, we're going to look at the deployment option for multiple regions. So obviously, across availability zone and definitely between regions, your cloud data egress costs can get pretty expensive. And so we want to limit the amount of data that we're pulling between regions. So you could set it up so that one exporter was scraping clusters across each region, but there's a lot of extra data in there, a lot of duplicate data that you don't necessarily need. So what I recommend doing is, let's say you have your cluster in region 1 and a cluster in region 2. Well, set up a Prometheus in region 1 with its own exporter and Prometheus in region 2 with its own exporter. And then you can set up Prometheus as a federator. And so what the federator does is it is designed to scrape Prometheus, and you specify the specific targets from Prometheus that you want. So let's say I want all of the data metrics or something like that. Well, here you would have the federator go and scrape Prometheus in both regions for the data metrics, and it's only going to pull the data that it needs. And then you can have Grafana present the data from the federator, not from the individual Prometheus nodes. And so while this is a little more complex to set up because you have 2 Prometheus nodes with an additional federator Prometheus node, this actually makes it much less data to pull between regions. And so it can save you quite a lot of money. What we're working on right now is an exporter per node. So instead of having an exporter outside of each node in the cluster, what we want to do is we want to be able to configure the exporter to say, I am running on a Couchbase node. So I only want to scrape localhost. And so the advantage to that is that it follows the standard microservices architecture. So every Couchbase node has a Couchbase exporter, has a node exporter, and has a process exporter. And every node in the cluster looks exactly the same. And so there's no external process running. There's nothing outside of the nodes to run. It also limits any additional nodes. You can see that we've saved a node that's out here in space from having to monitor each one of these nodes in the cluster. And if you're building out Couchbase using Chef with a recipe or Ansible with a configuration file or something like that, you can include your Couchbase exporter in the configuration so that it knows that for every Couchbase node I set up, I also have to set up these other processes. And so that can make your cluster build out much simpler. The disadvantage here is that your Prometheus rules become very, very complicated. Instead of having one node per cluster or one exporter per cluster or one exporter in general to scrape, now the Prometheus YAML file has to scrape every node in the cluster, which means that as you're changing your cluster configuration, whether through failover or adding nodes or whatever it is that you're going to do, you also have to update your Prometheus configuration file. Prometheus doesn't have any ability to auto-discover other nodes, where with the Couchbase exporter, once it bootstraps to a node, it will get the cluster configuration and start scraping from all the nodes that are running the service that you asked for in that cluster. And so you don't have to ever change your Prometheus configuration file unless you are adding a new service or adding a new cluster. So it would be very, very difficult to manage this Prometheus instance without also having the Prometheus autonomous operator, which means that you have to have Prometheus running in Kubernetes. And so that can make things very more complicated, but it does follow the microservices architecture, which can be a rule for a lot of organizations out there. So those are our main deployment models. This one is a future option. It is not currently configured, but we are working on getting it into production. So Cbstats. So anybody that's run Couchbase for really any amount of time has looked at MC timings and Cbstats. Cbstats is a tool that provides statistics about the data service. And it's on a specific node that you have to specify. So it doesn't get information about the cluster as a whole. It is only about that data node. The statistics that you're getting from Cbstats are also about an individual bucket. So you're not going to get in statistics about the entire data node. You're going to get it about each bucket that you ask for on each data node that you ask for. For the Couchbase exporter to use Cbstats, it has to have SSH access in order to invoke the Cbstats API. And so what that means is that you have to either have your Couchbase or your Couchbase exporter set up as an offline Couchbase node with Cbstats installed on it. You have to, and a SSH user that has key-based access to access itself, or you have to have a single node set up outside of the Couchbase exporter that runs as a Cbstats host that the exporter has a key-based access to, or you have to set up a user on each node in the Couchbase cluster that Cbstats has key-based access to. And you have to install that key into the exporter node. And what the exporter will then do is use that user to make an SSH connection to wherever you've configured it to make that connection to. And then it will be able to issue Cbstats. And these are really, really useful stats that aren't always available in the standard monitoring REST API. And so normally you would have to run this as an external process or something like that and kind of trend it over time. With this allows you to get those Cbstats on a 30-second or 1-minute basis or whatever you configure and load them into Grafana or into Prometheus, which is then available in Grafana. And that's very, very useful for looking at your Cbstats over time. You can take this and really, really understand what's going on with the data service in your cluster. And so here we go looking at the configuration for all the different ports that need to be set up. So Couchbase is going to be running on port 8091, like it always is. And you need port 22 for SSH for Cbstats from the exporter. The node exporter is running on port 9200 and the process exporter on 9256. Now, one of these has to get configured. I think it's 9256 because we also have some other processes that are running on its default port. And so we switch it to these ports so that there is no collision. Prometheus is running on port 9090 and Alert Manager on 9093. We have Grafana running on port 3000, and by default, Couchbase exporter is running on port 5000. And so you can see where everybody has to talk to each other, and it can get rather complex. All right, Prometheus. So if any of you guys have run Prometheus, you've seen Prometheus configuration files. And so there's an example Prometheus configuration file in our cbprometheus_python Git repo. And this is what the simplest configuration looks like. So you've got a scrape config set up with the job name of cluster 1. We're going to scrape every 30 seconds. And if it takes longer than 15 seconds, we're going to time out. It's going to scrape the /metrics path of our target localhost port 5000. So this will scrape the port 5000 of localhost at the path metrics. In this case, this wouldn't actually do anything useful, but hopefully you get the idea. So here's where we're going to scrape the query endpoint of localhost 5000. And we've named this cluster 1 query. All right, so to keep our processing and payload size down, we want to create a job for every Couchbase service. So like you saw here, this is for the query service, and we could include targets of multiple clusters here in our targets. If we're using the correct endpoint, we can configure our Git variables to only get specific nodes or specific services. And so instead of scraping every node in the cluster at once, we could set it up so that each node gets scraped individually. While that's typically not required, it is something that we can do. One of the things we also do is include the metrics renamer. So we want to take and prepend all of our data service commands or metrics with data underscore. This makes running things in Grafana much easier because anything with a data service is prefixed with data underscore. The metrics renamer, what it does is it looks at the metric that comes in, and if it is prepended with data, it drops it and adds data back to it. And if it doesn't have data included in it, it is going to prepend it with data underscore. And so it's very simple to set this up, and it's really, really useful when you get to building out your dashboards. You can also get it to drop metrics. So let's say I want to drop anything that includes replica, frag, or FTS. So in the data service, we have like the FTS DCP backlog. And we don't care about that because we're not actually replicating any data FTS because we're not using FTS. Well, we don't want to keep those metrics. And so this will remove those metrics from Prometheus so that we don't take up that extra space in Prometheus, because our Prometheus storage can get quite large over time. All right. So this is what Prometheus can look like. Here, I'm looking at CPU utilization rate of cluster 2 over an hour. And so this is our Prometheus endpoint. And we can see, we can enter any of the information, like any of the metrics we want in here, and we can include the different labels to bring this down to something simple. We'll get into how to do that in the demo. And this is PromQL. So just like we were doing CPU utilization rate, here we're getting from type system, where we get cluster 1, and we're specifying the nodes that we want. Over a 5-minute interval, we want to get the derivative. So what this tells us is that we want to look at how CPU utilization rate is changing over time in 5-minute intervals. And so there we can see we've got CPU utilization rate is negative, so our CPU utilization rate is going down, and then it's coming up. But obviously, looking at the scale, this is very, very small changes. So for the most part, our CPU utilization rate for this cluster is staying constant. And that can be considerably more useful than just looking at raw CPU utilization rate. If you want to look more at how to issue queries like this, you can look at prometheus.io/docs, Prometheus latest querying and basics. All right, so slow queries. So let's say you're using the Nickel service and you want to understand how different metrics are, or how your queries are running. So you want to look at your completed requests. And so here we've exposed some data that are possible for you to query so that you can see how your query performance is over time. So completed request query selectivity percent, scan results, fetches, things like that are important because you can start to see if your query performance is changing over time, or if your query performance is a lot better or a lot worse than you were expecting it was. Query request queue time and elapsed time are two very, very important metrics for understanding your query performance. Grafana. So Grafana is our visualization tool. It allows us to build very pretty dashboards from lots and lots of data sources and put them into graphs that make it very easy for people to understand. You know, if you see a line that's constantly increasing or constantly decreasing or steady, you know, anybody that's looking at that can pick out changes, and that's really where Grafana is very helpful. And you can overlay data from multiple sources. Like we're looking at Prometheus and graphite data. Well, let's overlay those data sources and look at how these two different systems are interacting or something like that. In our case, we're using it to monitor Couchbase, obviously. And we're going to be able to build custom dashboards, and we've provided some example dashboards in our repo that you can just import and have a cluster or have a dashboard for monitoring your cluster. Users are able to create dashboards that are specific to that user. So if Jimmy the operator needs a dashboard that is specific to disk utilization, he can build out that dashboard where the rest of the people may not care. Or DCP queues. So Jimmy thinks that DCP queues are indicative of an overall issue in the cluster. He wants to build out a dashboard for his project. He can build that out without impacting anybody else's dashboard. And if you're building out dashboards that are to be shared or be able to be made general, you can actually build out variables that allow you to select what you want your dashboard to present. So for our use cases, typically we have a dropdown for cluster and a dropdown for bucket and a dropdown for node. And that allows you to pick which cluster, which bucket, which node. For indexes, we're going to have a dropdown for the specific index. And variables make it so that our dashboards are generally useful. And you can find information about Grafana here at grafana.com/docs, Grafana latest. This is what a Grafana dashboard can look like. So here we've got a dropdown for cluster, a dropdown for node, bucket, index, and we've configured it to tell us if our nodes are healthy. This was actually built by one of my customers, which was very, very helpful. And we can see all the different information. And so this is a Grafana dashboard. All right, so now let's get into actually what we wanted to do here was the demo of this monitoring solution. So if you come here, we can see that this is my Couchbase cluster that I have set up. So we've got a 4-node cluster that is got 2 data services, and then we've taken and put the other services on our other 2 nodes. CPU, we could come here and we could look at our statistics. And see here we've got some operations happening. We're doing about 30 sets per second. Disk creates. Right now I've got just a little process that's running, generating load. And we can see that our we're actually mutating data. Got 3 buckets set up, a main bucket, a history bucket, and a metadata bucket. We have our query service. We've got some indexes set up. We've got some FTS indexes set up. We have an analytics service set up. And we've got some eventing functions built out. And like a good Couchbase developer, I have no views because we shouldn't have any views. All right, so like we were talking about earlier, the exporter is currently scraping this and looking at what's happening in the cluster. And so we can see here, this is what our endpoint looks like. So this is the buckets endpoint, and it's going to go through and scrape all of this data and stream it back to our browser. So we can see all, like, here's current connections. Okay. And this is our connect cluster, which we have named. If I come to settings, we can see our cluster name is connect. And the node I'm looking at here is connect 001, and it's a metric type of bucket. And here is the number of current connections against the cluster. And you can see that it's incrementing and decrementing and things like that over time. So how do we look at this over time? Well, Prometheus is scraping that. So if I do data, because remember, we have a metrics renamer going, _cur_connections. Now I can look at all the different current connections for the nodes in my cluster based on bucket and node. So I've got connections to main, HXN, and metadata, and I only have 2 nodes that are running the data service. So now if I wanted to look specifically at where I was only getting information about my main bucket, now I'm only getting information about the main bucket. And here I can look at the transactions over time. So you can see that here's where some connections happen and they drop. And then here's where I kicked off my little load generator. Now if I wanted to get about a specific node in the cluster, I could say, let's do, it's called Couchbase 001.connect. Port 8091 is how we identify these. And now I'm only going to look at that metric over time. So that's how it looks in Couchbase or in Prometheus. This is our Prometheus interface. And we can do all sorts of things here. Now, if we want to look at the targets that are set up, so here's where I'm scraping the analytics service. Here's where I'm scraping the bucket service. Cbstats, eventing, FTS, indexes, query, and system, XDCR, and then I'm getting metrics about Prometheus itself. And so let's look at the queries. So query underscore, let's see, complete a request, sure. Well, we don't have anything in there, but so here we're looking at average response time for both query nodes in the cluster. And so this is very, very useful and allows us to see, you know, when our query performance changed, which can be really helpful in determining things that happen. Obviously, right here is where I kicked off the load generator. And so that's our targets. We don't have any rules defined here. And this is what our Prometheus configuration file looks like. And so like I said earlier, an example of this is available in the CB Prometheus repo. So then we can come over to Alert Manager. Right now, we don't have any alerts that are firing. But if I were to come and let's see, so I can go and shut off a node or something like that, we could get alerts. Now, here's the configuration. We don't have any inhibits. We don't have anything configured for where those alerts would go. And we don't have any silences that are in place, but you would have the same PromQL for configuring which alerts or looking at the alerts that you wanted to follow. And so this is Alert Manager. Now here is Grafana. And so in Grafana, we provide you with a bunch of different dashboards. And thank you, Aaron Benton, for building out most of these dashboards. These are very, very useful. And then this one is actually built by Aniv Maskey, who is very helpful in building out this dashboard here. So this gives us an overview of the cluster. And so we can switch this to, let's say, the last 15 minutes and see that we are getting our, here's where I kicked it off and our number of sets per second. I'm looking at about 200, about almost 10K gets per second. And this is for the only cluster I have it monitoring. We could switch over and look at DCP and see how DCP is changing. And so we had no transactions, and now we've got these kind of transactions. And these that I'm changing up here at the top, these are our variables. And so I can look specifically at, which node I want to look at or which bucket I want to look at. And see here are the items sent, total bytes, items remaining. So it looks like we're draining DCP very, very quickly. We can look at our indexes and see our index RAM percent. Here's some information about our scan latency. So how long it's taking to scan our indexes, queries that are running, amount of memory used, things like that. And so this is Grafana. And this gives us a lot of information about what's happening in our cluster right now. We don't have XDCR configured, but we do have vBuckets. So this is more information specifically about our vBuckets, but you can configure and build these out yourself. You don't have to use the indexes or the dashboards that we provide out of the box. You could go and build your own dashboard. And in it, you could go and configure that you want to pull data from Prometheus and you wanted to get information about data like we were looking at earlier, current connections. And there, now we can see our current connections presented in Prometheus. And you can configure this with your different variables or build out variables or export your dashboards or anything like that. But this is how simple it is to build these out. If you only want to ever see information about the, let's see, the main bucket. Now we're only going to see information about the main bucket. And so typically you would turn this into a variable, but this is a very simple way of approaching the Grafana dashboard. And then queries, so we're not going to save that dashboard. But here's some information about the queries. Now, the way I've got this cluster built out, it's not issuing any queries that satisfy the slow query threshold. But let's see if we can get some to pop in here. Nope. Oh, this one might be a good one. And so it'll take a while because we only scrape this once every 30 seconds, but eventually that query will pop up in here and it will give us a bunch of information about that query. And so we could come and monitor that in a query monitor and see that issue, that query has been running for 31 seconds. But that is how to monitor a Couchbase cluster using Prometheus, Grafana, Couchbase, and Python. Once again, any questions you got, anything you want to go over, ask in the chat box. Need help getting this set up, or just want to talk about the architectural decisions that we made or things like that, let me know. And I'm glad to connect and talk about anything related to this that you'd like to cover.